Well, good afternoon, viewers. Today we have a 2008 Mercedes ML320 diesel. It's got 172,918 kilometers on it, and it has a drivability problem. It bucks significantly under a heavy load, almost like it's cutting out and going into safety fuel cutoff or something like that. Otherwise it runs fine. There's no check engine light. So we're going to scan it first and foremost and see if there's any codes to be reported. I got the scanner hooked up, got the vehicle idling and the AC on because it's freaking hot today. Hoping that there's going to be a fault code. You know, mileage concurs, VIN number concurs. I think I accidentally touched a... So I'm going to do a network code scan. I hope I can do that with it running. Is it a left-hand drive? Yes, it is. Charge pressure control too high. So why isn't the check engine light on? Boost pressure regulator. Position sense signal fault. Why would the charge air cooler hose cause charge pressure? Maybe that's the same generic code for low pressure too. Because if the charge air cooler hose was off, it would have low pressure. Speed sensor codes, implausible values from RPM sensors in the ABS system, under voltage at terminal 1, assist plus, signal acquisition module, signal line to component windshield washer fluid pump. All these are secondary issues. Not sending any data. Selector lever has been moved by the driver at a speed greater than 8 kilometers an hour. If there's no customer complaint, the fault can be erased. Well, is this thing done a network scan yet? I'm concerned about the fault codes in the engine control computer. No, it's still scanning. It's got 10 controllers so far, so we'll pick up when it gets to the end of the network scan. So we're about a minute and a half into this network code scan with 20 controllers, and I've noticed the radio display on a couple of occasions has flashed up the Mercedes logo and then flashed up a message saying diagnosis like that. I think that's just because we're doing a network code scan and it's interrupting communication. 26 controllers so far. And that's the end of the system report. So I'm not going to clear the codes on this thing just yet. I want to show you how this thing is driving. Might as well record some data while we're road testing it here. So I haven't cleared the codes. I'm going to check boost pressure control, diesel particulate, exhaust back pressure, hectopascals, intake air pressure, boost pressure. So we'll watch boost pressure and engine speed, but it doesn't give me desired boost pressure. Boost air temperature, intake. Okay, so we're going to go for a road test. Under normal driving conditions, it runs perfectly smooth, feels good, no noticeable lag in performance. It's only when you get on the throttle heavy. So I'm going to get off this gravel road and onto a pavement. Okay, so I'm going to accelerate fairly heavily now. It's just like it's going into safety fuel cutoff. You can see the effects of me trying to hold the camera steady. Okay, we're going to look at some data. Well, the recorded data doesn't really show me much, and plus it's painfully slow refresh rate. You can see the engine speeds fluctuating when I was accelerating here, but that's the result of it cutting out for whatever reason. So I'm going to clear the codes out of this thing and see if must be off, engine must be on. key on, engine off. Oh shoot, probably supposed to put it in park before you do that. I had it idling in drive. And let's shut it off. Restart it and see if the codes are present again. So there's a problem with the boost pressure regulator, and that's probably what's causing it, because it's acting like it's going into some kind of safety fuel cutoff. It's not over boosting, but it may think it is because of this boost pressure regulator position signal fault. So we're going to go back to the shop and do some research. So I'm pretty sure our problem is with this motor actuator here that controls the turbo wastegate, but I'm having difficulty finding any service literature as usual. Even using the component level testing in the Snap-on Verus, it doesn't have this ML320. It has a 350, which is gas. But this is CDI, diesel. So we're still looking. So the fault code is a 2510, which refers to item Y771, which is this item here, wastegate position sensor of some type. It's got 3 wires on it, so I would think that that's a position sensor. But going on the service literature and looking up guided component tests for this vehicle, I went back several years, trying different years, 2008, and as you can see, there is no ML320. Maybe it was only sold in Canada. That's a possibility, but it's not there. There's a ML350 4MATIC, but that's gas. Fun times. Well, I got my hopes up here for a second. I see DTC 2510, which is the one I have. Click on that. DTC troubleshooting. Click on that. Oops. And guess what? It's troubleshooting for the transmission. I guess that 2510 is a fault code for the transmission engaging with torque converter lockups clutch not permitted. Well, that's obviously not the trouble code we want. As I said before, Mercedes doesn't publish troubleshooting charts to my knowledge. They are part of their scan tool, their Eccentric scan tool, which I do not have, of course. So this is a picture of the turbocharger assembly, and this is under component description and operation. It's a variable vane, so it has, it's much like the GM Duramax turbochargers. So that position sensor, or that position component, said here is adjustment of the turbine geometry of the turbocharger takes place via the boost pressure potential positioner. And obviously there's a position sensor in there, but I can't find any information on how to test it yet. Well, best resource I've found so far is YouTube, believe it or not. Thanks, kudos to Tim's Road Trains. I'll put a link in the description. He shows a common failure item on these are these 2 contacts on this turbo actuator. And apparently they crack, cold solder joint cracks, and if you can get that off of the vehicle without taking the whole actuator assembly off, you might be able to repair it by just resoldering these 2 electrical terminals. So once it's cooled off, we're going to give that a try. So I've let it cool off. We're going to go ahead and remove this actuator, at least just the front cover here, and see if that electrical circuit has failed, as it seems to be fairly common. Also going to check the air filters. God knows when they've been checked last. I know they typically gets it done at an oil change place, but they typically don't check these air filters because they're too difficult. So disconnect the 2 sensors on the air duct and loosen the 3 hose clamps, and you can pull this air induction system out. Disconnect the, I guess that's the PCV vent. Check the turbo to see if there was any play in it, and there isn't. It turns nice and smooth. Can't feel any axial or radial play in the turbocharger, which is good. So there are 6 little U-shaped clips that hold this cover on. You can get at all of them pretty easy except the bottom one, but the bottom one will pop off if you tilt this forward at the top, and it'll pop off on its own. The majority of the time I see that people leave that one because it's nearly impossible to get back on. So we've got this out, and we're going to examine these 2 terminals to see if there's any broken solder joints. Can't see anything. So all the research that I found says these 2 terminals, look at that, that one's broken off. This one's okay. No, this one's broken off too. Boy, that's pretty shitty design. This one's broken off, and this one's broken off. See if I can zoom in on that a little bit. Yeah, they're both broken off. I wonder if they're actually supposed to be soldered or just, wow. I wonder what the success rate of soldering this is. Well, we're going to give it a try. So those 2 little terminals, those little pads, are zinc plated or something. I couldn't get the solder to stick to it, so I've used a sharp screwdriver here to scratch the coating off the surface to see if I can tin it now. There's a tin that's on there, whatever is on the surface, the solder won't stick to it. And I got the soldering iron heated up to 400 degrees Fahrenheit. But I think if I can get through to the copper down here on these 2 terminals, I can get it to tin. And I'll have to find a little piece of copper wire. Wow. I mean, it's no good anyway, so if this doesn't work, we'll order up an actuator. But I heard some rumors about it being serviced with the turbo. That would be kind of stupid. Let's get that cleaned up. Well, not the best soldering job, but managed to get it to stick. Well, I'm going to put it back together and see what happens. So that's the unit back installed again, but I decided I'd check the air filter because God knows if it's ever been checked. It's quite an operation to get it out. You can't take the cover screws off, so you have to take the whole housing out. There's 2, I guess they're E8 or something like that, bolts, and take the duct off, but you have to take that firewall backing out. But anyways, I got this right side off, and what do you think? Do you think it needs an air filter? Wow. That can't make it run very well either. So there's the air filter on the driver's side. Both of them are completely plugged. Well, let's see if we can source a couple of air filters. Take this thing for a road test. So I got it back together without air filters in it, of course. But I'm going to scan it to see if it cleared that code. Okay, that's in history. Let's try clearing it now. And let's read it again and see if it's still there. I think it does say that. Oh, I think I had to have it running. That's right. I'm going to start it up. Okay, so we're going to try this process again with it running this time. Here it says must be on and engine off. But last time I cleared the codes, it didn't clear it. Some systems require the engine to be started or need a test drive before the codes disappear. Well, let's take it for a test drive. Actually, I'm going to try this actuator test. Charge pressure positioner. See if I see that thing moving. You know, I didn't see it move during the test, so that's not a good sign. So I'm going to try accelerating heavily now and see how it runs. Definitely runs a lot better. I'm sure the air filters helped. Let's try it from a stop. It's making, I can't see the writing, I gotta stop and look at it. Boost pressure. Cut out there for a second, there it goes again. Way better than it was, but it's still not right. Now it's gone into reduced power of some kind. I'll check engine light, that's what bugs me. Well, let's see what codes we have. So it made up to 2,791 hectopascals of boost pressure. We weren't getting that kind of boost pressure before, but that could be because of the plugged air filters. Let's see what codes it's generated. Charge pressure too high. I'll bet you there's still a problem with the vanes on this thing. 2510. I'm not sure if that's the same code we had before, but we didn't have this one. So I bet you that actuator is seized in the turbo. Okay, so I was able to clear the codes out this time. So I'm going to road test this thing. Watch boost pressure. Boost pressure in hectopascals. Intake air pressure in hectopascals. It's gone into a reduced power now again. It's not making any boost anymore. It hit 2799 hectopascals. I don't know what that is in PSI. I can't relate to hectopascals. But I'm sure that we got a code again. Let's see what code has returned. 2510 and 2359. Okay, I wonder if there's an easy way to check to see if that turbo is seized. So this thing is smoking hot, but this is the wastegate actuator rod right here. And then once it cools off in the morning, we're going to try disconnecting that rod and see if the vanes move in the turbocharger. Is it a problem with the actuator, or is it a problem with the actual turbo geometry vanes? It's somewhat like a Duramax. It doesn't work on them either. So here's a case history for the code 2510. Complained his engine light on, low power. Well, we don't have an engine light for whatever reason, but we do have the code. Fault code for charge pressure control or low boost pressure is set. Remove and inspect for blocked air filters. They're not blocked anymore. Check turbo impeller for wear and rotation. It turns smooth and it doesn't have axial or vertical play. Replace turbo with motor as an assembly if damage is found. Be sure to, let's see what this says. Once it sets the code, it reduces engine power, but otherwise it runs good. No more bucking like it was doing before. Perform activation of the intake air throttle motor located at the front of the engine. Remove pipes. Oh, could indicate inspection for restricted exhaust. Factory scan tool has been operation for turbo and will regulate EGR, engine RPM, set turbo specified position. Well, this scan tool has the capacity to command the turbocharger wastegate to move, and it doesn't move. So either the actuator has failed or the turbo is stuck. And I'm starting to lean towards the turbo stuck. Who knows how long that's been like that, where it hasn't been operational. Like here. 2510, you look, you think, oh my goodness, we're going to find a diagnostic flow chart. DTC troubleshooting, and it's in the transmission. Oh well, it's so freaking hot now I can't touch it, so I'm going to wait for it to cool off in the morning. I'm going to try and disconnect that linkage. There's a couple of clips on it and see if the turbo moves. So that's the circlip from the top of the link inside here, and I've got it disconnected from the actuator, and the turbo moves nice and free. So we're going to take this actuator off again, and maybe I missed one of the other wires, or maybe one of my solder joints didn't work, or maybe we just got to replace this actuator assembly. So I did find one of my soldered connections that was questionable, so I resoldered it, and I was able to clear the codes now. Let's try that functional test on the actuator. See if it works without it running. It says it's supposed to be running. Actually worked that time. I'll set this up over there so you can see it. So I'll start the actuator test again. Seems to stroke now. Well, let's try a test running. I'm going to take this thing for a road test. So I'm going to try the test again with it running. Yeah, you can definitely hear the turbo spooling up now. So maybe my first soldering attempt didn't work. Let's see if we got any codes back. Wow. Well, the proof is in the road test. Okay, so we got this thing back together and running, and boost pressure right now shows at an idle 939 hectopascals. on the previous road test it hit 2,799 hectopascals, which is roughly 40 pounds boost. But that's absolute, so you got to take off roughly 14.5 pounds for atmospheric pressure, or 900 hectopascals. So we're going to see how it performs now that the turbo appears to be working. So I'm going to get on the throttle a little bit now. We're making good power. 2320. I think what was happening was the wastegate was stuck in the full boost position and it would overboost, and then the engine would take protective measures for the rest of that drive cycle. Surprising how good it runs now. Well, we'll order up that air induction hose, because that, if that leaks, it'll be unfiltered air getting into the air turbo and intake. But it's making nice boost pressure now, and it doesn't appear to be losing power, and it's not cutting back. When I get back, I'll check it for codes. So the max boost we reached on that road test is 2,588 hectopascals, and no fault code set as far as I can tell. At least it's still performing and running good. I'm going to save this recording for future reference. Let's check for codes. Well, that's a good sign. So I don't know what's up with this check engine light not working. It does work when you turn the key on. There it is, just above the clock, or just above the fuel gauge, I should say. But it was never on for any of these codes. Now we're going to see if we can reset this service reminder. But that's it for now. Thanks for watching.